right, today we're going to talk about rate of change and slope. Now we're really starting to get into some of the major aspects of algebra, and this is going to help us along the way when we're graphing lines, when we're figuring out different things. So rate of change is a ratio that describes on average how much one quantity changes with respect to the change in another quantity. The main thing we need to remember is it's the change in y over the change in x. And this is the part that you're probably going to have the biggest difficulty with, is saying the change in y over the change in x. That's where most of the mistakes occur. Some of you want to put x over y, but remember it's y over x. So the first thing this problem says is determine the rate of change. So what I'm going to do is I'm going to pick two values from my y column, okay? And I'm going to say 96 minus 48. That's how we determine the change in y. Now, since I chose 96 and 48, in that order, I have to choose 6 and 3. So over 6 minus 3. Okay, if I chose 144 and 48, I would have to chosen 9 and 3. So 96 minus 48, and we get 48 all over 3. And 48 is going to end up, 48 divided by 3 is going to be 16. So my rate of change is going to be 16 for this. Now the meaning of rate of change, what this means is that there's 16 square inches, 16 square inches of surface is tiled for each floor tile that is used. Okay, so the number of tiles, the area tiled. So there's 16, each tile basically is 16 square inches. 16 square inches is the area of one tile. All right, it's almost kind of like a unit rate is what this is kind of telling us, okay? Now, rate of change, that works pretty well, but really what we want to talk a lot about, and we need to know about rate of change. I'm not discounting it in any way whatsoever, but what we want to focus on as well is slope, okay? So, the slope of a non-vertical line. Okay, non-vertical means doesn't go up and down. It's the ratio of change in y coordinates to the change to x coordinates, all right? So it's the ratio change in y coordinates to x coordinates. Another way that you might see that is rise over run. Remember, y goes up and down, right? That's our y. And run, we say left and right. That's our x coordinates. That's why we're saying, again, rate of change, we took y over x. Right? Here with slope, we're talking y over x. So there's a couple of ways that we can go ahead and figure this out. Let's do it the non-mathematical way. If I want to figure out what the slope of this line is, I'm going to start at point L. I'm going to start at point K. Okay? I'm going to rise up from K, 1, 2, 3. You see how I did that? That's 1, 2, 3. That's my top number. That's my rise. And then my run going along the x is going to be 1. So my slope, I'll call it as 3. Okay. Now, let's go ahead and put this along with what we talked about in last class. If we want to put it in slope-intercept form, Remember we talked about that and we said y equals mx plus b. Okay, I just figured out my slope is 3. I'll put my x and my y-intercept, remember that's my b, it's going to be 1, 2, 3 plus negative 3. We were just able to create a slope-intercept form or create an equation out of that line. Okay, but let's just talk about rise over run. Okay, so here from R to Q, and it would work if I went from S to Q as well. It would just be a fraction I would have to reduce. From R to Q, I'm going to go up 2, that's my rise, my run, but goes negative over negative 1. So my slope is going to be negative 2. If you have a negative slope, your line is a negative line. If you have a positive slope, this is what we call a positive line or a positive slope. So, again, using that y equals mx plus b, this is just information that you'll need sooner or later. Here's my slope of negative 2, so y equals negative 2x, y equals, plus my y-intercept of negative 1, negative 2, negative 3, plus negative 3. Just so happens this line goes through negative 3 as well. All right. We can also do this by determining the change in y-coordinates over the change in x-coordinates. So here I have point B, and that's going to be negative 2, 0. And here I have point C, which is 1, 2, 3, 4, 1, 2, 3, 4, which is 4, 4. Okay, so what I want to do is I want to figure out the change in y, so I'm going to say 4 minus 0. Remember, I had to take my y values first, over the change in x, which is 4 minus negative 2. So 4 minus 0 is 4. 4 minus negative 2 is 6. So it's going to end up being a slope of 2/3. Okay, a slope of 2/3. So let's go ahead and test this out. Now I can go from A to B. Up 2, that's my rise, over 1, 2, 3, that's my run. Sure enough, that checks out. Okay, so I have some other points that I want to work out. I'm going to go ahead and erase this. The points are given. So the first thing I'm going to do is the change in y. So that's 5 minus 0 over the change in x. 1 minus negative 2. 5 minus 0, 5. 1 plus 2 is 3. So my slope for that is 5/3. Negative 3, 4, and 2, negative 3. So I'm going to do my change in y, start with my y. So I have negative 3 minus 4 over 2 minus negative 3. Negative 3 minus 4, that's negative 7. 2 minus negative 3, that's going to be 5. So my slope here is negative 7/5. Finally, I have negative 3, negative 1, and 2, negative 1. So I'm going to say negative 1 minus negative 3, 2, I'm sorry, that was wrong. See, I even need to underline my y value so I don't mess up. Negative 1 minus negative 1, and 2 minus negative 3. So I have negative 1 minus negative 1, and that's 0. 2 minus negative 3, that's 5. So that's going to be a slope of 0. Okay, that means there's no slope at all for this one. And basically what that means is that, see where our y value is negative 1? So it would be a line that goes straight across, side to side, at negative 1. If I was to graph it on this graph here, it would be a line kind of like this. Okay, so it has no slope whatsoever. Okay, so there's a couple of other things that we want to go ahead and talk about. And this was a slope of 0, okay? That's the line that goes side to side. And then sometimes there's an undefined slope. For instance, if I had something that was 4, 3, and 4, negative 2. Okay, so if I go ahead and do the go ahead and determine the slope, I say negative 2, underline my y's, minus 3, and 4 minus 4. So I end up with negative 5 over 0. You cannot divide by 0. Even if you put it in your calculator, negative 5 divided by 0, your calculator will come up with an error. That's why we call this an undefined slope. The line goes straight up and down, but we call that undefined. So real quickly, in your notes here, there's just a positive slope, we talked about that. Negative slope, we've looked at that. A slope of 0, and then finally our undefined slope. These are 4 things that you need to become familiar with, as well as, and we'll practice this in class, how to determine the slope of a line. Thank you.